Hello everyone on today's Flutter Cracow meetup. My name is Kamil Rykowski and I will be talking about, as mentioned, about the async way of Flutter. So it would be mostly a topic of how to handle the asynchronous code, what about the execution model of the Dart, and what the hell is the event loop. So let's begin with a quick introduction about myself. I'm Kamil and I work as a software developer for more than 10 years now. With the Flutter itself, I've been working since 2018, before the first stable release. Currently, I'm working with the Lab for Life local startup as a Flutter developer. We are building a mobile app to extend people's life in health. So we'll see at the end of the year if we succeeded or not. And personally, I am a cross-platform freak, so I'm always excited for cross-platform technologies like the Cordova, Ionic, Xamarin, basically anything which you can use to build cross-platform apps. But since these 2 years, I've been almost all my time put into developing in a Flutter because I believe that's the future for now. And other than that, I'm blogging on my blog at Rykowski Dev, which is available in Polish. So if you speak Polish and if you can read Polish, then feel free to visit the blog and learn some Flutter topics. So let's begin with the most important part, because not every Flutter developer knows it, is the fact that the Dart itself is a single-threaded language. So it has a single-threaded execution model. So it's not like a C# or like Java, where we have a multi-threaded language. The Dart itself can do only one thing at a time. So you cannot perform more operations. Well, you could, but we'll talk about it later on. But the nature of the single-threaded languages is the fact that you cannot perform more than one operation at a single point of time, which could sound like it's a bit slow because one operation at a time is meh. You could probably disagree with the fact because you already wrote some Flutter applications and your apps are doing a lot of stuff at the same time. But that's not really true. That's probably because the hardware in our smartphones is so fast that it could imitate that it's performing a lot of stuff at the same time. But the single-threaded is not a curse. It's more like a blessing just for me because I'm from Python, which is also a single-threaded. We have a lot of benefits from such a concept. The first one is that there are no interruptions. So if you run your program, then no other thread can stop your app because there is no other thread which can access the memory of your thread. So it cannot interrupt it. The other thing is that we don't have any deadlocks. We don't have any race conditions. If you've been working with a multi-threaded programming language, you probably noticed or get familiar with concepts like a race condition, where you're accessing a same address in the memory by multiple threads. Here, it's not a thing because, as I mentioned, you have only one thread, so there's no competitors here. So there's no one to race with. And of course, all these rules applies to the Dart. This applies to the Flutter because Flutter is using the Dart as a programming language, and any rule which applies to Dart applies to the Flutter as well. And it's not only about the async code or, I don't know, the execution model or anything like this. Every rule which applies to the Dart applies also to the Flutter. So we have to deal with it. Here we have some quick code. It doesn't use any asynchronous operations. So it simply provides some main function, which will print the start main, then it will print the result of the random sort, and then it will print the end main to the console. Running such code makes us a guarantee that it won't be interrupted. No other thread can stop us, like we will print the start main and that's it because some other thread killed us. Well, the user could kill the application, but that's a bit different story. If the random sort would be using some global variables then we are sure that there won't be any deadlocks, like other thread is also using this particular variable, because we have only a single thread. So that's it. We have a lot of guarantees about how the code would work when we execute it. And that was an synchronous code. So what about the async one? Because synchronous is quite easy to follow, because you run some code, you get the response. You run some code, you get the response, and so on and so on. And it's a bit different when you're working with the async code, because just like in a synchronous code, you start it. Okay, so I'm starting some function. That's okay. But you don't get the result immediately. The asynchronous code will finish some point in the future. So you're not gonna to get the response or the result of the function just right away. And why is that? Imagine a situation where you are sending HTTP request to your API server. So you are sending some data over the network. Even if Dart would like to give you the response immediately, that's not possible from the technical point of view, because this data need to go to your server, and it depends if it's online or offline. It all depends on the internet connection on the mobile phone. If is it slow or maybe it's fast, and it's hard to determine how long will this code perform. So instead of getting the response immediately, you will get it later on. And the good fact, so without this point, that it's do not block rest of your code. So if you're running some asynchronous code, it doesn't block your main thread, because if it would block, then imagine a situation where you're sending some request to the network and whole your application freezes, because it simply proceeds the request. It cannot do anything else. So the user cannot tap on the buttons, he cannot scroll. So that would be, let's say, sad. That would be really sad. So instead, Dart do not block your application and performs other synchronous code in the app which you wrote. And the asynchronous code is not strictly, but is most of the time related to the I/O, so input-output operations, like a network request where you want to communicate with your server, but also with when you are reading or writing local files, because that's also not tightly coupled to your CPU. It's more about a disk controller in your smartphone or desktop or whatever you wish. But as you proceed with building a Flutter application, you encounter that basically half of your stuff is asynchronous. That's a case for our applications which we are building. How Dart could, because I said that it doesn't block, so it's performing some operation in the background, and the Dart itself can still be responsive, so it can still make some operations. And how is that possible? That's is the answer. It's about event loop. If you've been working with, for example, the Node.js or even the JavaScript itself, then you are familiar with the concept of the event loop. These are big words for something as easy as an infinite loop to process up events. So basically, it's some kind of loop which is a while true, do something. That's it. That's an event loop. And what are the up events? Is like hunting that user tapped somewhere on the screen, or he swiped, or anything the user can perform in the application, like a double tap or a single tap. It doesn't matter. All of these are events which are handled by the event loop, which is working under the hood. Fetching HTTP responses, like you're sending some request to your server, but when the response comes back, it's not returned to to your application. It's returned to the event loop, which proceeds it. And when the time comes, You can probably parse your HTTP response or do whatever you want with it. There are also timers, like if you want to run some code every 5 seconds or so, it's also produced by the event loop. And the main difference between the event loop in the Dart and the JS is the fact that it has 2 queues instead of 1. And also worth mentioning is the fact it's working in a FIFO, so first in, first out. So it proceeds the oldest events as first. So if you got first to the queue, then you will be proceeded first. And you have 2 queues, the micro task with a high priority and an event, which is a normal priority. I didn't put here a word low because that's probably what you would be thinking, because there's a high and a low. No, the event queue is a normal priority and micro task is a high one. And to be honest, you probably don't need to ever use the micro task in most of your mobile applications. Just because it means that it's a high priority, it doesn't mean that you want to use it. Simply ignore it, just keep in mind that it exists. But most of the async operations would be performed on an event queue. So you have, just like in a JS, a single queue which you want to use for real. And here's some kind of implementation of how do I imagine the event loop, like it's some while true. At first, it pops the first micro task from the queue and it runs it. So it runs the code associated with this particular task. If there is no micro task on the queue, then it pops the event from the events queue. If there is any, then it's run, and then the loop proceeds again and again and again. Basically, as long as the application is active. So as long as the application is running on a mobile phone or the tab is open in the Chrome, then the event loop is proceeding and is parsing the events and the tasks. All right, so that's been a theoretical approach. Let's talk about something more serious, so more practical on how to work with this. So in the Dart itself, we have some concept called futures. And the future is, even if it looks different, looking at the code or the execution, it's run asynchronously. It doesn't run in parallel. And what's the difference is that there is still a single thread. So even if you're running some asynchronous code, it still proceeds by a single thread. So it cannot run in parallel just by the nature of the thread. There's only a single thread. The futures are executed on the event queue. So remember that I said that you're going to use the event queue. That's because the futures are handled by the event queue. And in most of the mobile apps in Flutter, you would be dealing with the futures itself. And the future has 3 states. When you create an object of the instance of the class, the future, it would have a state like a new, so it's uncompleted. So that's the state of the future where you are sending. So I've just sent HTTP request to my server, and I've got a handler to some object, which is a future, and it will have a state that it's new, it's uncompleted. It doesn't know what the response from the server is yet. The next state is successful. So we have a full response in our future object because the server responded with for example, currently logged in user. So we have this object in our future. And the third state is a failed state. So the future has completed, but with error. So that's not exactly what we wanted, but during handling the future on the event loop, some error occurred, some exception has been raised, and the future is in failed state. All right, so how to work with the futures itself in the Flutter? First thing first, we need to import the Dart async module. So that's the first thing if you want to work with the futures in the Flutter. And here we have some code, like we are printing the start main, then we are building our new object the instance of the future. So here we go. We have a future constructor which accepts some function. We created this object, and then we have printed end main. And what would be the response of it is the start main, end main, and future is now. It's not quite obvious at the first glance. Why is that? Because reading the code from top to the bottom, it should be a bit different. But remember how the execution model works. First thing is that it executes all the synchronous code. So synchronous print start main, then it encounters creating a new future object. All right, it will create the future object synchronously, but it won't run this function because this function would be handled by the event loop, which is only triggered when there are no more synchronous operations. And at the bottom, we have an end main, so it's still a synchronous operation. So we need to run this first, then we've done with all our synchronous operations, and that's the time for the event loop to see if do we have any micro task. No, I don't think so. So do we have any events on our event queue? Yep, we have one, because the future are handled on the event queue. So then at the end, we have the future is now. And that's how working with the future looks like in the Flutter. We also have an API, because simply creating some futures is not enough. We have some API to play with it. And the most important is then method. Just like in the previous example, we are creating some future. In the future, we are printing the future is now. We are returning some value. Later on in the line 10, we are creating another future. Then we are printing some code. And the most important part is here. Like we are calling the future, that's the instance of the future, and we are calling the function then. So what does it mean is that when this particular future comes to the completed state, then run this function. And if we run this code, we'll have, like in the previous example, the start main, end main, because these are the synchronous operations, so they run first. Then we'll have the future is now, because this future in the line 6 has been created previously, before where am I. And after that, we got the old man, because we're calling this function in the then callback. Worth mentioning and worth remembering is that then is not handled by as a separate event on the event queue. It's run synchronously. So whether this future completed, it looks for all the callbacks which should be handled through then, and they are run synchronously just before giving control back to the event loop. And at the end, the second future is triggered. We also have some API for catching errors and when complete. And to be honest, I haven't really used this for like since I started with Flutter. To be honest, I don't really like this API. Like we have a future, just like in the previous examples, and we have a then, so we know what then is. We have a catch error. What's a catch error is the thing like our future comes from the new state to the failed state. So it failed for some reason. And the future can fail if it raises an exception. So in this example, you can see that we are throwing some exception. So the catch error would be triggered. And the when complete is the function which will be called basically when the future becomes failed or successful. So there is a big or, so it doesn't really matter which state would we end up, is it success or not, we'll always get into the when complete. So in this example, we see a start main, end main, future is now because that's the code of our future, and then alt main 2 and 3. So we are totally ignoring the fact that we had then print altman 1 because the future didn't succeed, it failed. So it didn't change its state from new to completed. Instead, it goes from the new to the failed state. So we are only running this catch error and when completed because it always runs. And why don't I like this concept or this API of dealing with the futures is the fact. Here we have some snippet from the official Flutter plugin for handling the cloud functions. We discovered it in the team, and it's not that we like to dig into the code base just for fun and see how a lot of things are implemented. It's because we had some serious problem in handling exceptions in our code base. So as you can see, here we have some try-catch statement. So we are trying to catch some exceptions. Then we are running some function called call cloud function. Here we have a then. So we can assume that this call cloud function is asynchronous because it returns future. That's because here we have a then, and then we are providing some callback to parse this particular response. And the developer put, of course, everything in a try-catch statement, but it doesn't really matter because that's not how you deal with an asynchronous errors. You should put here and catch error in order to catch asynchronous error or exception. In this particular implementation, it won't catch the platform exception like this, and it won't wrap it into cloud functions exception. So this code won't be ever run, that's sad. But instead, if any error will occurs here, it will be simply rethrown, like in this particular code. So this API is error prone, and that's the reason why I don't like it. We have an alternative, and the alternative solution is the async await keywords, which are available in Dart. On the left side, you have the syntax, which is using the then function, and on the right side, you have the async await. And what's the difference is that whether you are going to use the await keyword, you need to put async keyword in the function declaration. So here you need to put async just after the main, just in order to tell the compiler that, all right, that's gonna be async function, and I would be using await keyword in there. If you will forget it, don't worry, the linter will tell you about it. And here we have a await future print future is now. And what does it do is that it awaits till this future finishes. So both of these examples do the same thing, but in a bigger code base, it's much easier to follow code which is wrote using the async and await. Because let's see on another example, it simplifies the execution flow. Because I've got rid of all then, when complete, catch error, and replace this with the await. So when you want to, here again, we can see that I've used a try catch to catch an asynchronous exceptions. And I said that's bad. Yeah, that's bad when you don't use the await keyword. Because when you do use the await, then the try catch can catch the exception which is raised. So that's greatest thing which could happen to you as a developer, because with the async and await, you can write your asynchronous code just like it's synchronous. And the other great thing is that you can again read the code from top to the bottom. You don't really mind about all this then, what's the synchronous, what's the asynchronous. You simply read your code from top to the bottom. And the result of it is a start main, future is now, oops, and end main. So it's much more easier to follow such code because Here we are waiting for the future. We are printing some code, we are throwing an exception, and this exception is cached by a typical standard try-catch block, and it prints oops. If we would forget about this await, then the try-catch won't catch our exceptions. So that's the most important parts, that the code is easier to maintain, easier to read, and yeah, definitely use the async and await. This one is just an interesting topic, that why shouldn't you use microtasks? Because they are greedy. So in this particular example, I'm printing the start main, creating some future object, scheduling microtask. That's basically like create a microtask on the microtask queue. Then I'm calling some attention please, which is scheduling a microtask, which will call attention please, which will schedule a microtask. You got the point. Then scheduling a microtask. And what's the output of it is that we are printing the start main, end main, because that's asynchronous. We are printing the micro 1, micro 2, and what would happen next? Nothing, basically nothing, because we of course scheduled some event which should print a future is now, but it won't ever be executed because we are scheduling a microtask in an infinite recursion loop. So we'll always have some microtasks to trigger, so which should be run. So our whole application got freezed, and it would simply execute only the microtasks. It's such concept. It's not possible using the event loop and the futures. It's hardly possible even using the schedule microtask, because we are developers, we know what we are doing. But that's one of the reasons why should you avoid the microtask. So that is a single threaded. And what about the concurrency? Because I need to run some code in parallel. I simply need to. So how can I achieve that? Through the isolates. The isolate is a Dart version of a thread, but it doesn't mean that Dart is a multi-threaded language, because the threads which can be spawned, or isolates, have no shared memory. They are totally separated. So no race conditions, no deadlocks again. They have a separate event loop. So each isolate is more like a totally separated application rather than a simple thread. The isolates communicates through some ports, through the receive port and a send port, and they are parallel when possible according to the docs. So if there is a possibility to run this thread in parallel, or this isolate to be more specific, then it would be run in parallel. And here is a Dart way of isolates, on how to deal with the isolates. I'm not gonna go through this code because the whole concept of the isolates is a cool topic for another presentation. You can simply see that there is a bunch of code to make isolates work using a pure Dart implementation. We are creating some receive port, spawning some isolates, sending some send ports. To be honest, I'm not able to implement it up from my head because I'm not doing it too often. Instead, when I need to deal with the isolates, I'm using the compute function. That's a built-in function in the Flutter, which you can use to spawn some isolate, pass some arguments into it, and then proceed with whatever the output is. And that's it. You don't need to worry about providing any kind of send port, receive port. This particular approach is quite easy to use, but limited a bit, because you can only run it once, get the output, and that's it. There is no communication in a real time. And as you can see here, I've used the await keyword, which means basically that the compute is returning some kind of future. And that's it, because every time you see await, it means that on the right side, you have some kind of future. And basically, I'm talking about this isolates and in parallel execution. And why should I ever use it is that you should use the isolates for heavy computations to offload the main thread. So for example, if you need to proceed with your images, or if you need to parse the video or process some kind of heavy file, which otherwise kill your main thread and make the app unresponsive, then go ahead, use the isolates. For example, in our application, we are using the isolate to perform the calculations of the expected time of living in health of a given user according to a lot of data. Such calculation takes too much time to be performed on the main thread, so we are offloading it to the isolate and waiting till it finishes. So to wrap it up, Dart is a single threaded, and it doesn't mean it's slow because it has an event loop, and if needed, it has an isolates. Keep in mind the event loop and the event queue. Just forget about the microtask queue, you probably won't need it. Switch your syntax into async and await to mimic synchronous flow, because it's much easier to read and maintain code if you don't need to mess around with all this catcher, then, when complete, and so on. And the last point is that do not use isolates in a Flutter driver. I'm not sure if that's still the point, but in the previous version of the Flutter, probably in the current version, that's the same story. The isolates do not work when you run the Flutter driver. It simply stops the isolate immediately, and it won't be performing correctly. So you need to mock it, fake it, whatever, but simply don't. All right, that's it for the asynchronous programming in the Dart, in the Flutter. Thank you very much, and I guess I will be seeing the questions right now, if any.
Yeah. Thanks, Kamil. Thanks. It was really valuable. So yeah, like once again, you can post your questions on our Slido channel. Also, if you would like to post it here, like please go ahead. So far, we have only one question. I think it was at the very beginning of your talk, and one of the person asked if you could repeat on the gesture part, user gesture part. I think you mentioned it at the beginning of your talk.
About the gestures. Let me see what was there. Which was it? Let me share the screen again. All right, so here we had something about the user gestures, like tapping or scrolling. Is that the question about?
Yeah, so the question was about repeating the user gesture part. So I guess that's that part as you found right now.
All right, so I don't really know what should I repeat, but I will make it maybe more clear about what it's about. So we have an event loop which is performing in the background, and whether the user is tapping on the screen or he's scrolling the list or whatever does he do, it works in such way that the Flutter engine captures the event which is performed by the user, and it doesn't immediately passes it to the correct widget which should handle it, for example, the list view or anything like this. Instead, a new event is produced and it's put on the event loop. And starting from now, the event loop will proceed with this particular event, whether possible. The fun fact about all these user gestures is the fact that even if we'll freeze our mobile application, for example, by performing some heavy computations, it doesn't mean that the thread which is responsible for capturing all these events from the user, it's still working. So it still accepts the gesture from the user. So the application could feel like it's unresponsive and it doesn't accept anything, but that's not true. the event loop will still capture the events, and when the application will unfreeze, then the event loop will pick up the next events on the queue and it will proceed. Like it would press, for example, the button for like 100 times if the application has been unresponsive for that long.
Okay, thanks for that. We have a couple more questions. So the most popular question right now. So what's a Flutter driver?
What's the Flutter driver?
Yes, exactly.
That's the question. All right. So the Flutter driver is basically a tool which could be used to write end-to-end tests. So, for example, you're writing a test for your application, which would be driven by a Flutter driver. And that's a kind of test where you're testing basically a built application like a whole. You are not testing some kind of function, or you are not testing a single widget. Instead, you are telling the Flutter driver, all right, that's my application, go and click through it. And you can, for example, tell Flutter driver, all right, run this application, then find on the screen a button which has text login, please press it. After you press it, then on the screen should be shown some red warning like, enter the username first, you dummy. Then the Flutter driver enters some text into the text field. So you're basically programming some bot, some kind of robot, which will play around with your application, and it will see if it works as expected, if it shows the correct images on a given screens, or if the button is responsive, and so on, so on. So you're writing simply some kind of automated tests, like in a web world, you will be using, for example, Selenium to test your web application.
Okay, thanks for that. The second question, or maybe some kind of request. So can you link the issue of the isolates in Flutter driver?
Sure. I will find it out and we'll post it on a Zoom chat.
Okay, great. We can do it as well. The next question. So how does the Dart perform in comparison, let's say, to JavaScript or to C#, like from performance perspective?
Well, I haven't really run any kind of benchmarks on how many operations can it perform in a second, because that would be a quite heavy task to do, to provide some benchmark which would tell us some meaningful data about how can it perform. If I would need to talk about the performance, then it would be really hard to compare it with languages like Java or C# or anything which is multi-threaded, because we don't have a multi-threaded environment and we cannot perform the tasks in such manner. It's much easier to compare Dart with the JavaScript because both are single-threaded, both have the same execution model, which is an event loop. So maybe there are some kind of benchmarks on which one is faster. I don't know the answer for it, but if you are, for example, wondering whether the Flutter can be a smooth application and can it perform really smooth on end user devices, then the answer is yes. I didn't really encounter any problems. Well, we have encountered some of the problems during the implementation, during the development, but basically that's the case for any language. So you cannot avoid any performance issues working on a software. In some of time, you simply need to stop, see where's the problems, use, the Dart have excellent Dart dev tools, which you can use to find the bottlenecks in your performance and work around about that.
Okay, sounds good. Another question to you, Kamil. Can you access files or network in compute method?
Yeah, that's a tricky because when we are running our application, our Flutter application, then the main thread has access to, for example, the assets which we have in our application because it's communicating to the platform channel and so on. But we can for sure send HTTP requests from the new isolate which will spawn. I don't know if we can access the assets of the mobile application. We didn't have such approach. We didn't really use it in our app, and I didn't really test it. But it's worth investigating if that's possible.
Okay, thanks for that. We have another one. So, are there any ways of optimizing Dart code? I'm not talking about writing efficient code, but some Dart tricks, if there are any.
Yeah, about the tricks. Like 2 or 3 months ago, I've been responsible for a full sprint story, which has been responsible about increasing the performance of our mobile app because we had some serious problems. And my advice is to run the application in a release mode, for example, or a profile mode, run the dev tools and see the profiling tools. There is not much resources about it, how to use it on the internet. So you will need to try it on and see how exactly to find bottlenecks in your application. So that's the thing which you should perform when your application becomes heavier and heavier. But the other one is that as a developer, you are responsible for thinking about the features which you are implementing. And if you are aware that some kind of computations are really heavy and you see that your application got slowed down even a bit after implementing some feature, then you should think about moving some particular code into the isolate, because isolate is run on a separate thread. So whatever operations you would perform there won't be affecting the responsiveness of the application itself. So for example, I've had this example in my presentation. Like I had this particular random sort algorithm. So it's not most effective way of sorting a list by randomly shuffling it and seeing if it's sorted. That's probably the worst algorithm which I could think of. But if you would run this on the main thread of our application, the application would freeze. So that's a good indicator that if your app is freezing after running some function, then you should put this code into the isolate. So there are probably no other tricks like that.
Okay, yeah, that sounds reasonable. Thanks for that. And I think that we will have the last question to you, Kamil. So when I have a big list of images, should I do every calculation on bitmap in isolate?
It depends on how much time is it needed by calculating this bitmap. So if it's like more like few milliseconds, so then you will probably notice a lot of frame drops. So I would probably go into spawning separate isolates, but I would be a bit afraid on what exactly is the list of images, how big is the list, and if you're rendering all the images, for example, at once without, for example, list view builder. Because if so, let's assume that you want to show all the images at once and you want for each image spawn an isolate, then that's a horrible idea, because spawning an isolate requires some resources. So it's not a free operation to spawn an isolate. If you're gonna spawn, for example, 1,000 isolates at once when the user is entering some screen, oh boy, that would be. I assume that your app will probably crash due to the missing resources like memory. We've had a similar problem when we've been doing it in our application, and it's not been that big number like 1,000. So instead, I would think about some kind of queue, like spawn only up to, for example, 50 or 100 isolates and proceeds whether this queue has any free resources, and then repeat the process. Because spawning too much isolates is also not a good idea.